Hello grade 8, today we're going to start a new unit which is electrochemistry. What is electrochemistry? Electrochemistry is a branch of chemistry that deals with the relations between electrical and chemical phenomena. In another word, is the study of chemical processes that cause electrons to move, and the movement of electrons will generate electricity. We will discuss this later. So let's start now with chapter 1. Chapter 1 is called Oxidation and Reduction Reactions, and today we're going to discuss the first part, oxidation number. The objectives of our session is to explain what oxidation numbers and how they are assigned, and then we're going to solve some applications. Let's start. What is an oxidation number? Oxidation number is a whole algebraic number. It can be positive or negative that indicates how many electrons an atom has gained, lost, or shared when bonding with other atoms. So there are 8 rules in assigning the oxidation number. They are very easy to be memorized. Just pay attention. Let's start by the first rule. The first rule is the oxidation number of an element in its elemental form is 0. Elemental form means when the element is not bonded with another element. Example, we have here carbon, the oxidation number is 0. The magnesium, the oxidation number of Mg is 0 لأنه they are not bonded with other atoms. We have exception here, oxygen, O2 and Cl2. They are exceptions. They are bonded, but why? Because they are found naturally as diatomic molecules. لأنه Cl is not stable alone, so it needs to be bonded with another Cl atom, and this is also for oxygen. Okay, so the oxidation number of an element is an elemental in its elemental form is 0. Now the second rule. The second rule says the oxidation number of monoatomic ion is equal to its ionic charge. Monoatomic ions هن ions of one atom. For example, we have Na. As you know, the Na, when it loses one electron, it becomes Na plus. This is the ionization equation. Okay, so it loses one electron to become Na plus, positive charge. So the charge of this, the ionic charge of this ion is 1 plus. Okay, so the magnesium atom, the oxidation number of magnesium atom اللي هي المغنيسيوم ion, when it becomes an ion يعني بتصير Mg2 plus, so it is plus 2. Oxidation number of O2 minus, when it loses 2 electrons, the oxidation number is minus 2. Note that we have here the oxidation number is written in Roman number, and it is preceded by the charge. Okay. The third rule, it's for compounds. Compounds, they are substances formed of 2 or more chemically bonded elements. Okay, if the elements in the compound are in group 1, يعني column 1, the charge, the oxidation number is +1. And elements of group 1 or column 1, they are hydrogen, lithium, sodium, and potassium. With respect to if the elements are in column 2, group 2, the oxidation number is +2. Okay, and the elements of column 2, they are Be, Mg, and Ca, calcium. Aluminium, if it's found in a compound, its oxidation number is +3, and fluorine F, if it is found in a compound, its oxidation number is -1. You should memorize these rules. Okay. The fourth one says the oxidation number of a hydrogen when combined with non-metals is +1. For example, we have a hydrogen in HCl, and H is bonded to NaCl اللي هو non-metal, so its oxidation number is +1. The fifth rule says the oxidation number of oxygen in most compounds is -2, but exception, we have an exception, oxidation number of oxygen in hydrogen peroxide, yani if we have a compound H2O2, the oxidation number of oxygen in this compound is -2. طيب, oxidation number of H is what? Let's return here. When it's combined with non-metal, it's +1. So the oxidation number of H in H2O2 is +1. Okay? The sixth one says the algebraic sum of individual oxidation numbers of all atoms in the formula of compound is 0. يعني the elements, the summation of oxidation number of the elements found in a compound is equal to 0. For example, this is compound NaCl. The summation of the oxidation number of Na and Cl is equal to 0. The seventh rule says that the algebraic sum of the individual oxidation numbers of all atoms in the formula of polyatomic ion is equal to the charge of the ion. Polyatomic ion يعني it's made up of more than one atom, and ion لأنه it has a charge. So for example, the oxidation number of PO4 all 3 minus, and it has the charge of 3 minus, this is a polyatomic ion, it's equal to -3, equal to its charge. The last rule in assigning the oxidation number says that the oxidation number of elements is designated by, of other elements is designated by X. For example, if you come across an element other than the mentioned, just designate it by X instead of writing the oxidation number لأنه it's unknown. So write X. Let's start by the first application. The first application says calculate the oxidation number of S in magnesium sulfate اللي هي MgSO4. First of all, MgSO4 is what? Is a polyatomic compound. So the summation of the oxidation numbers of the atoms is equal to 0. Type. The Mg, you know, when it's in a compound, its oxidation number is +2. S, we don't know it, and we want to find it, so it's X. Oxygen, when it's bounded, when it's found in a chemical compound other than H2O2, it's -2. Sorry. Okay. So هون بس عشان it's +2. So what do we have here? We have magnesium +2 يعني 2 plus X plus double oxygen. How many atoms we have? 4. So 4 times -2 equals to 0. And by solving this equation, you get that X equals to 6. So the oxidation number of S in this compound MgSO4 is 6. +6. You should write the positive, the plus sign, and 6 in Roman number, VI. The second application. The second application says calculate the oxidation number of N in NO2 minus. Type. This is an ionic or polyatomic ion. Polyatomic ion, the summation of the oxidation number of its atoms is equal to its charge. What's the charge here? -1. So the summation of oxidation number of atoms is equal to its charge, so it's -1. What do we have here? We have N, we don't know it, so it's X. We have O2, O is what? -2, and we have 2 atoms. So X plus 2 into -2. 2 لأنه we have 2 oxygen atoms, and -2 is the oxidation number, which equals 2 -1 is the charge. So by solving this equation, we get x equal 3. So the oxidation number of N in NO2 minus is equal to plus 3. Akid, you should write it in Roman number. Application 3, which is the last application, we have calculate the oxidation number of P in Cu3PO4 given an oxidation number of Cu is plus 2. So it's given, we have the oxidation number of Cu is plus 2. What do we have here? This compound is what? Is a polyatomic compound. So the summation of oxidation number of the atoms present in this compound is equal to 0. Okay, what do we have here? Cu it's given plus 2 type. Plus 2, this means we have a 3, since we have a 3 Cu, so 3 times 2. The P, it's the unknown that we need to calculate it. It's X. O, it's what? Minus 2. And here, how many O atoms we have? If you can see, before O, P, how many P atoms we have? We have 2, لأنه inside the brackets, and P is multiplied, 2 is multiplied here. Okay, here we have 1, so times 2, it will have here 2 P atoms. Okay, after that we have here, with respect to oxygen, 2 times 4 we have, so 8 oxygen atoms. So 3 times plus 2, which is the oxidation number of copper, Cu, plus 2x, 2 لأنه we have 2 P atoms, and x, it's the oxidation number. After that we have, look here, 2 times 4. Why? لأنه عندنا هون 4 oxygen atoms, and we have another subscript times 2, so 8, 2 times 4 into what? Minus 2 اللي هي oxidation number of oxygen. Okay, equals to 0. So by solving the equation, you get that x equal to 5. So the oxidation number of P in this compound Cu3PO4 2 is equal to plus 5. So by this application, we ended our today's session. If you have any questions, please don't hesitate to ask me. Goodbye.